If you don't remember how to put points on the graph and draw the line, you should see this video about the equation of the straight line before continuing. Speed-time graphs. Speed-time graphs give information about the motion of an object that is accelerating. Speed-time graphs are a way of visually expressing a journey with speed on the y-axis and time on the x-axis, and it shows how the object's speed changes as it moves. Pay attention in this example. The speeds of a car traveling on a straight road are given in the table below at successive intervals of 1 second. Draw a speed-time graph for this motion. We will see speed-time graphs to find two things: total distance and acceleration. Now let's see how to find acceleration. Acceleration is the gradient of a speed-time graph. The gradient of a speed-time graph tells us whether the object's speed has been changing at a high rate or a low rate or not at all. Gradient is y change over x change. X change is time. Y change is change in speed. So the gradient is the acceleration. In this case, change in speed is 8, time is 4, the acceleration is 2 meters per second squared. Another example. A toy car is placed on the floor of a sports hall. It moves in a straight line starting from rest. It travels with constant acceleration for 4 seconds, reaching a speed of 5 meters per second. It then slows down with constant deceleration for 2 seconds. It then stops. Draw a speed-time graph for the toy car. It moves in a straight line starting from rest. The initial speed is 0. It travels with constant acceleration for 4 seconds, reaching a speed of 5 meters per second. It then slows down with constant deceleration for 2 seconds. It then stops. Find out the accelerations. The car accelerated from 0 to 5 meters per second over the first 4 seconds. Let's calculate the gradient. Change in speed is 5, time is 4. The acceleration is 1.25 meters per second squared. Between 4 and 6 seconds. Let's calculate the gradient. change in speed is minus 5 times 2. The acceleration is negative. Now we will use the speed-time graph to find the distance. Example. A car moves in a straight line starting from rest. It travels with constant acceleration for 4 seconds, reaching a speed of 5 meters per second. Calculate the distance traveled by the car in this time of 4 seconds. Let's take the graph from the previous example. Now, let's calculate the area under the graph. If you do not remember how to find the area of the triangle, you should see this video before continuing. Area of triangle is base times height over 2. The base is 4 seconds. Height is 5 meters per second. The area is 10 meters, but meter is the distance unit. Then, the distance can be found by calculating the total area of the shaded section below the line. Let's see how it works. The speed-time graph below represents the motion of a car along a straight road for a period of 30 seconds. Determine the acceleration of the car. We should calculate the gradient. The gradient is acceleration. Acceleration is negative because the car is slowing down. What is the total distance traveled? If you don't remember how to find area of the trapezium, you should see this video before continuing. This is the formula to find the area of trapezium. Pay attention. The total distance traveled is 420 meters. Example. The speed time graph below shows the speed of a car for the first 40 seconds. Describe the car journey. Between 0 and 10 seconds, the speed increases. So there is acceleration. Let's find acceleration calculating the gradient. Change in speed is 15 meters per second. Time is 10 seconds. The acceleration is 1.5 meters per second squared. Between 10 and 20 seconds, speed did not change. There is no acceleration. Between 20 and 40 seconds, the speed decreases. So there is acceleration, negative acceleration, because the car is slowing down. The car accelerated from 0 to 15 meters per second over the first 10 seconds. The acceleration was 1.5 meters per second squared. Then, the line is flat, meaning the car's speed was not changing for 10 seconds. It was moving at constant speed. Next, the car spent the last 20 seconds decelerating back down to 0 meters per second. The acceleration was minus 0.75 meters per second squared. Find the total distance covered by the car. Distance is given by the area. Trapezium area. The distance is 375 meters.